Welcome to Networks Professionals.
All right, let's jump right in. We're going to tackle the world of artificial intelligence. Now, I know, it's an industry that's just swimming in acronyms and jargon. It can feel like trying to learn a whole new language. But don't worry, today we're going to decode that alphabet soup and make sense of the key terms that are literally building our future. Let's get to it. You're using AI all the time, probably without even thinking about it. When you ask ChatGPT a question, tell your smart speaker what song to play, or even just unlock your phone with your face, that's all AI. But have you ever just stopped and wondered, what's actually going on behind the scenes? What are the real building blocks that make all of that magic happen? Well, that's exactly what we're going to pull apart today. So, here's our game plan. We're going to start with the hardware, the actual brains of the operation. Then we'll get into the operational backbone, how it's all managed and kept running. After that, we'll see how AI is getting closer to us, living right on our devices. And we'll wrap up with how we actually give AI a voice, so we can talk to it like we're talking to a person.
Okay, first stop, the engine room. To pull off the kind of stuff we're seeing from AI these days, you need a staggering amount of computing power. This is the hardware, the physical brain doing all that incredibly heavy lifting.
So first up is a term you might recognize from the world of PC gaming, the GPU, or Graphics Processing Unit. And it turns out the very thing that makes them amazing for video games, their ability to do thousands of calculations all at the same time, which is called parallel processing, is also the perfect skill for the ridiculously demanding job of training an AI model. This massive multitasking ability is why GPUs are the absolute workhorses of AI.
And then you've got this guy, the TPU, or Tensor Processing Unit. Now, if the GPU is a powerful, all-purpose workhorse, think of the TPU as a finely tuned race car. It's something called an ASIC, an application-specific integrated circuit. All that really means is that it's a chip that was built from the ground up for one job and one job only, making machine learning workloads go incredibly fast. It's all about pure, specialized speed. So let's just put them side by side to make it super clear. The GPU is your powerful do-it-all engine that you use for that initial, heavy-duty work of training the AI. But the TPU is the specialist you call in to make that fully trained model run at lightning speed. It's kind of like the difference between a heavy-duty truck that can haul anything you throw at it and a Formula One car that's built for nothing but speed on the racetrack. You need both, but for totally different stages of the process.
Okay, so we've got the brains, but how do we actually manage all that power and get these amazing AI models into the apps and services we use every single day? Well, that leads us to the operational backbone.
And this is where a term like MLOps comes into play. It stands for Machine Learning Operations, and it's the super important behind-the-scenes work that makes sure AI services are actually reliable. Think of it like the stage crew for a huge Broadway show. MLOps takes the amazing AI model from the lab and gets it ready for the main stage, keeps an eye on it, updates it, and just makes sure the whole show runs smoothly without a hitch. It's really the unsung hero of the entire AI world.
So how do we, the users, actually get our hands on these AI tools? Well, most of the time, it's through something called SaaS, or Software as a Service. This is just a way of saying you're using a powerful program over the internet, kind of like a subscription to Netflix or Spotify. ChatGPT is the perfect example, right? You don't own the giant AI model, you're just tapping into its power through your browser. But what happens when another app wants to borrow some of that AI power? Well, that's the job of the API, the Application Programming Interface. The easiest way to think about an API is to picture a waiter at a restaurant. Your app is the customer. It gives its order, a request, to the API, who is the waiter. The waiter takes that request to the kitchen, the big AI model. The kitchen prepares the response, gives it back to the waiter, and the waiter brings it right back to your app. It's the essential messenger that lets all these different pieces of software talk to each other.
Up until now, we've basically been talking about AI that lives in these enormous data centers, somewhere far away in the cloud. But there's a really big shift happening right now to bring all of that intelligence a whole lot closer to home.
And that shift is called Edge AI. The edge here just means your local device, your phone, your smartwatch, your car. So Edge AI means the thinking, the processing, is happening right there on the device itself, instead of sending your data on a round trip to some server miles away. And that's awesome for two big reasons. First, it cuts down on latency, that annoying lag, so things feel instantaneous. And second, it's a huge win for privacy, because your personal data doesn't have to leave your device in the first place.
And you are using this stuff constantly.
That moment your phone unlocks just by seeing your face, that's Edge AI. Your smart thermostat that learns your daily routine, yep, Edge AI. The voice assistant in your car that answers you in a split second, that is all happening right there on the local hardware.
So we've got the brain, we've got the delivery system, and we've even brought the intelligence right onto our devices. For the last piece of this puzzle, let's look at the part that feels the most human, how we actually talk to these machines and how they talk back to us.
The whole scientific field dedicated to this is called NLP, or Natural Language Processing. This is basically the magic that acts as a translator between our messy, nuanced human languages and the rigid, logical world of computers. It's all about teaching machines how to read, understand what we mean, and even generate language that sounds like it came from a person. Now, when it comes to a spoken conversation, you can really break NLP down into two simple parts. First, the AI has to be able to listen to you. It needs ears. And then, after it figures out a reply, it needs to be able to speak it back to you. It needs a mouth.
The ears are ASR, which stands for Automatic Speech Recognition. This is the tech that turns your spoken words into text on your phone. It's what lets a smart assistant understand what you're asking. It literally takes the sound waves from your voice and translates them into digital text that a computer can work with.
And the mouth? Well, that's TTS, or text-to-speech. As soon as the AI has its answer ready in text form, TTS is what turns that text back into audible, spoken words. And honestly, it's incredible how far TTS has come. I mean, we've gone from those old, robotic, Stephen Hawking-like voices to the amazingly natural-sounding assistants we interact with today. And there you have it. That's our whole journey in a nutshell. We started with the brains, the GPUs and TPUs. We moved to the operational backbone that keeps it all going, MLOps, SAS, and APIs. We saw how Edge AI brings all that computing power right to your fingertips, and we wrapped up with how NLP, using ASR for ears and TTS for a mouth, gives AI its voice. You know, this isn't just about learning a few new vocabulary words. Every single term we just talked about is a fundamental piece of the future that is being built right now all around us. Understanding these concepts gives you a kind of blueprint to the world of tomorrow.
So I'll just leave you with this final thought. We've just opened up the toolkit for modern artificial intelligence, from the silicon chips that do the thinking to the sound of its voice. Now that we know what's in the box, the question isn't really what AI can do anymore, it's what do we want to build with it next?
Thanks for watching.